30 seconds. All right, let's get started. First off, thank you everyone for coming in this early after a night of a few drinks and some fun. So really appreciate getting up and coming to our session. So let me introduce our speakers. So first speaker needs no introduction, Mike Furgal, who's been working with Progress very long time.
1989 at Progress.
1989, and who graciously came out of retirement just to do our session. So thank you, Mike. Really appreciate it. Next, we have Vladimir Soloviev, Senior DBA, Infor QED consultant, and currently managing over 100 databases. And myself, I'm the president of OmegaServe and Senior DBA since 2000. Just to tell you a little bit about OmegaServe. So we're a managed services company. We monitor databases 24/7. Our main goal, or two main goals, is to always make sure you're up and make sure your environment is performing at its best. And we're also official ProTop resellers. And that's it. We offer different DBA-related services, reorgs, health checks, disaster recovery strategies, stuff like that. All right? So in this session, we're going to describe doing an online dump and load using table partitioning. We're going to start with a live demo, so everybody cross your fingers.
Maybe.
Maybe. And then we're going to describe how we did this in production recently, and explain all the caveats and gotchas that we discover along the way. So just a warning: your mileage will vary because every environment is different. So what we're going to go through over there, it's not a step-by-step guide to get you to do to achieve the same result. So it's something that has to be tested extensively and reviewed on a case-by-case basis. All right, over to you.
So back in 2016, Patrice from Proganov approached me and said, with table partitioning, you can do a dump and load by moving data from one partition to another partition. So he challenged me to go figure this out. I went and created an environment to go do this, and I did a presentation in 2016. Does anybody remember that presentation? Besides Tom, okay. So the whole entire presentation was based on that demonstration. Well, I could take an hour to go through that, but I'm going to shortcut it this time. So what you do is described here. You add an integer field to a table and give it an initial value of 0. Add an index on this new field, and then you enable table partitioning. And you make what's called a list partition, where the value 0 lives in the exact storage area where that table lives today. And when you change the value to be 1, then that rows with the value of 1 will be assigned to a different storage area. So you could imagine, as you have a row in a table that has a value of 0, it's in the storage area A. You just go update that value to be 1, and now that data has to migrate from storage area A to storage area B. And this happens all online because table partitioning is designed to be an online utility. So as part of doing this, it's going to move your data into a fresh storage area, and it's going to move it in the order that you want. You can use any index that you want to get it to move, because you're just writing a 4GL program. Tell me how to get this to go forward.
Right button.
You do it. This is how the day has gone so far for me.
That's a demo effect.
Okay.
Okay. Yeah. All right. Got it.
Okay, so here's the demo, and there is a demo. Create a demo database, add 500,000 rows to the database, make it fragmented. Add the integer field my area, add an index to the my area integer, enable table partitioning, run an application, move the data, check the results. So I've done steps 1, 2, 3, 4, 5, 6, all set up here in the demo. So I'm not going to go through all that because that should be known, and if it's not known, you can go back to the 2016 Pug Challenge slides, and you can get step-by-step on how to do it, because I did this in spent an hour doing that entire thing. So now I'm just going to show you that this actually works, I hope, and then after that I'm going to hand this off to the guys that did it live. Want to hold this?
Okay, fingers crossed, everybody. Fingers crossed for the live demo.
There must be something about this room.
Another word of advice, don't do this on a Mac.
Uh-oh.
Okay, so I'm not going to do a demo. So let's just move on to the rest of the presentation, because I can't seem to get the secure CRT to come up.
It's when you select it, it's coming up on the top left, so it's there.
You saw it?
I think it's hidden on a different screen.
Say that again?
I think it's hidden on a different screen.
I looked. So there's no other
When you
screens.
select it, it comes up on the top menu bar.
So go where?
So when you actually select it, you see that it swaps to secure CRT at the top, so it's not connected. But there's somewhere.
So they're here, right?
It's on, there we go.
Okay.
All right.
Hold on. I have 4 windows. Give me a second. Window, this one.
It's not Windows, remember?
Don't X the window, okay. Window, this one. And that is read. One more, and we will be on our way. So, if you guys can see this, which I hope you can. I'll take the microphone. So if you guys can see this, this one here is the application that's going to move the data from one storage area to the other storage area. And this is the application. It's just doing it for each, and it's just going to for each this table as the table is being migrated. So that's what's going on here, is just these 2 programs, and then these 2 windows are going to be doing all the work. So, of course not. Okay, so it looks like it might be just a network problem. So this program over here is going to just be running the read program. That's this program down here that's just doing a read. And this one, and the other one's going to be doing a move. So here's the one on the right is just doing this read program that you can see at the bottom. The one on the left is doing the move program. This is probably going to take about 2 or 3 minutes for the data to get migrated. There's 500,000 rows in here, and it is fragmented. I'll show you the fragmentation, and we can run a DB analysis after and see that the fragmentation is gone. But now we're just watching. And when I did this in 2016, what was happening, so we're going to see the rows move. Every 50,000 rows, you can see that we've processed these. This will give us a sense of how long it's going to take. The timing on the left started going faster and faster and faster. And why is that? Because I purposely fragmented these records. How did I do that? I created a demo database and I loaded up 500,000 records. Then I went and updated the records after I had done that to make the address bigger. So now they're fragmented because they don't fit in the same block. So the first part of the record fits in the original block, and then when I added the address, it split that record into 2 blocks. So it just fragmented the record. So hopefully as we get through this, we should start seeing the left-hand column start going faster, because now half of the rows are no longer fragmented as we read through them. But this is a little bit like watching paint dry. So while we're watching paint dry, I'm going to show you the DB analysis from I had before, so you can see what the fragmentation looks like. So if you look at this, we're in a partition, and the fragmentation factor is 2.0. What's this telling you is we have 500,033 rows with 948,000 fragments in that row. So this is, every single row has multiple blocks for each record. And we're halfway through from, from the timing standpoint, from 7:10 to 7:12, so we got about 2 more minutes to go, and we'll see this go. We'll run the DB analysis. You'll see the fragmentation's gone. Then I'm going to hand it over to the real experts that did this in a live environment. Because since I did this in 2016, it was a nice, as Rich Banville called it, he said that was cute, right? That you could use table partitioning to do this, because that really wasn't the intention of table partitioning. But I have not known any production customer to have done that up until today. And so that's what Vladimir is going to be talking about, and Nectar is going to be talking about. So again, we're watching paint dry for another minute or so.
While we're watching the paint dry, how many of you are using table partitioning currently?
Okay.
Oh,
So that's one, by the way, for the one person that raised his hand. So just as an aside, I had this all set up on a machine that Gus has that we did for the bunker talk that we're doing tomorrow morning. And it was all set to go. I checked it last night, working fine. Wouldn't you know, this morning, the machine, you can't connect to it. So you always have to have plan B. So plan B, this is just a little machine I have in the cloud that I used to play with, and I had this set up, but I didn't trust that. I didn't think we were going to need this, so I was like, okay, now what do I need to do? So I built this demo up this morning just to make sure that it worked. So we can see here that it's actually happening now. So we were consistently 10 seconds, 11 seconds, 12 seconds, and now we're getting almost all the way through the move of the data, and the times are getting a little bit faster. It's not consistently fast because we have this other application running that's moving data, and as soon as that's done, we should start seeing this speed up. And if you remember, the top number at 10:51, that was without this program running. So then the program ran and things got slower because now data's moving out from underneath it. And eventually, when this completes, we'll see that it's now faster. And 10% faster is significant, even though it's only 10 seconds. It's got a very small minus B. Not intentionally, just regular, just
Oh,
I
there we
think
go.
10,000 blocks, which would be ridiculously small, but there's not a lot of memory on this machine because, again, it's just a toy. Okay, so this one's done. It took, that long to go, and now we should see this thing run, and it should be running faster. Is that the case? 5 seconds. So we went from 10 seconds to 5 seconds at just doing an online table move. So at this point, I'm going to say ta-da, and you guys can clap, okay? I would do a DB analysis, but that's going to take another 5 minutes, so I'm not going to do it because you can see the results here. So let's go back to the presentation because I know these guys have a lot to talk about, but this is what inspired them to be able to do this on the live environment. So let me get the presentation back up.
I have a question.
Yeah.
Yes, I heard a question.
Yeah. Why is the number of records changing for each loop?
The number of records are not changing. They're 500,000 to 33.
Now, in the first page, you had at the end 30 and 31.
On this other side?
Yeah.
So this is.
On the left side, the display was not the same. I'm sorry.
So the number of records, I didn't see the number of records changed. They did? They shouldn't have. But that could be a concern of maybe there was a record in transition, because this is doing if the value is if you look at the code.
Your bank account.
Yeah, I know. Yeah. We have to be careful here, right? I don't have I'd have to see it. I don't have an explanation for that. Okay, so I'm back to.
Was different before.
Okay, you have the clicker?
I do.
You go. It's back to you. Just get to the slide. Okay, so I'm done. I'm now just going to be the heckler to help these guys out a little bit. So I'm moving off the stage. Oh, hold on. I think these are my two slides. So here's the benefit, right? You have control over moving the rows.
You cannot leave.
You can do it. You can do it. You can do it anytime you want. It's restartable because it's just a 4GL program. You can do it. You can do it at night. You can put sleep time in there if it impacts the user. You can do it over weeks. You can make a temporary storage area and move the smaller tables out and then move them back, because sometimes you might want to have your tables connected to each other because they make logical sense to be in the same storage area. So if you move them to another storage area, well, now they're not logically connected. Keep going. Oh, and it does not. This is the big one. It does not cause an OE replication rebaseline. So if you did an offline dump, load, index, rebuild, you have to rebaseline OE replication. One more. Caveats: you need to have the table partitioning licensing. So it's not free. It's not part of the standard enterprise. But if you have the advanced enterprise, it's part of that. The new area is now part of the database. It's going to be part of your backups. So we're going to be backing up to that high watermark, and that high watermark will not change unless you truncate it. And the only way to truncate it is to offline truncation, and then you have to rebaseline OE replication. So that's a caveat. So the OE replication thing, while you can do this and not affect OE replication, if you want to reclaim unused space, well, then you have to deal with it. Backups will be larger, and beware of code that does rec ID lookups. So you can do a find first customer. I found my customer, and I'm going to go update the customer, and you're going to pass, instead of passing a buffer to it, you pass the rec ID of the row, and then that update goes and does a find by rec ID. Well, the rec ID is going to change. When it moves from storage area 1 to storage area 2, as process, it's going to have a new rec ID. So you might have found it when it was in storage area 1, and you go look for it, and it's now in storage area 2, and its rec ID changed. So you may find a different row, or you may not find the row at all. I think that was the end of me.
Yep.
Okay. Now I'm done.
Should be closed.
Tom? Well, Tom. So speaking of rec IDs changing, how does that impact Pro 2? Well, this will fire CDC, I believe, but it will not fire replication triggers. So if it fires CDC, then Pro 2 should survive it because it's going to go find the old record, delete it, and create a new record. It's going to slow things down a lot. It'll see the initial record as being deleted. But if you have replication triggers, the triggers will not fire because this is happening all below the language layer, and the triggers are in the language. Okay, really got to give this to these guys.
Thanks, Mike. So, anybody got excited yet? No? No? Not at all? Like, that's strange. So, I was excited, like, a few years ago when I was on this presentation, I was like literally jumping up and down because, hey, like, he called it, what did he call it? Nirvana. I don't know what he meant by that. Like, nirvana means, relaxation. I was literally jumping like up and down because, like, just like Nectar came from QAD world, he was working for QAD, right, for years. I came from Infor professional services. Like, another, big competitor to QAD, like in distribution world, ERP system, like progress-based. So what I was doing for quite a few years, doing services and upgrades like for distribution system, and every distribution center, warehouse in North America I know about, they had weekends. So like it's beautiful, like, you as a DBA, you can take the database down, you do dump and load, so it was not a concern. Like, and suddenly the company I work for, in a different business. It's in logistics business, okay? And literally first month I started working with them, I realized, oh, you're not even allowed to take the database down. I mean, like, trackers are standing, crossing the border. And so, no. They cannot wait until, Vladimir finished the dump and load. Like, it doesn't work that way. So, like, no downtime, like, allowed. Like, almost, like, I'm exaggerating. But when I saw what Mike did, like, I was like, oh, that's a solution. Like, that's beautiful. That's a solution. So, that's a landscape. More than 100 databases sitting on more than 20 servers, like more than 10 terabyte worth of data, thousands of customers. It's split, like every database represents a customer, some big, some small, but up to 400-500 concurrent users in a database. So again, like that was a solution I saw, and interesting enough, like 3 years after presentation, right, Mike? I approached Mike asking, like, do you know anybody who did it, like, in production? He said, no. Like, why? Like, no, why? I don't know. When COVID happened...
License cost is one, right? Because how many people have the table partitioning license? So we have one there, we know that's running it, and about a handful more. If you have the Advanced Enterprise Edition, you have it as part of it. But if you have the Enterprise Edition, and I'm sure a lot of people do because they had it before the Advanced Enterprise came out, and you have no reason to trade in and upgrade, you'd have to go buy the license. And then if you're going to buy the license, you need to have a reason to buy the license. And is this online dump and load the reason? You have to pitch that pretty well to management to get that to happen.
Again, it took some time. The famous joke about difference between tourism and immigration. I know it firsthand. So whatever Mike did was tourism, demo database in a bunker, whatever. Do it with like real users was little different. So, but we went through this, right? And that's a landscape. Again, service level agreement has a, we have a constraint about the downtime, and customers are really strict about it. So we had to be very careful with that.
Yeah.
And Nectar can explain like what we did and what we selected, like how we did it.
Right. So why do this in the first place? Why go through all this trouble? We saw the presentation. Well, we want to maximize performance as much as we can. It has a huge impact. Hundreds of environments, like Vladimir said. And doing this online would be essential because it's very difficult to get to organize downtime for this particular landscape. And we needed something that we could easily scale to those 100 environments, something that we can develop once in one environment, get it going, and then do it quickly on all the others, and not have to do a dump and load on each and every environment. And, have actually a weekend off from time to time. So doing it online, we avoid the outage. We avoid doing the record validation before and after, because we're not really purging and putting records back. We're just changing a field like we saw in the demo. And we reduce the risk factor, because when you do a dump and load, you have a list of steps that you must follow, and of course we manage this risk. We have a checklist and everything, but there's still a risk that something can go wrong Monday morning. So, and this is why we got excited with this solution. So we picked one of the environments, and we looked through the tables. What would be a good table to try this on? So we picked a table with the highest scatter factor, 80% fragmentation factor, called order track. Another one, order header, which only has a 20% fragmentation, but it's a very extensively used table. Like, I don't know, something like 60 to 80% of the application uses this table, writes to this table in and out. So even though it would only be a 20% performance increase, the impact would be pretty large. And then finally, there's a huge audit table that we were looking at, but as you can see, the scatter factor, the records are pretty contingent. There's no fragmentation there. So there is some value in partitioning it, but not in the exercise that...
So Vladimir was all excited about this table. 258 gigabytes, I want to use this one. And I was like, why? And then we found out nobody reads it. It's an audit table. So I said, why? So it's exciting to go do an online dump and load of a 250 gigabyte table, but you got to say, why? Why are you doing that? So that one was thrown onto the floor just because there's no value to it. It's just gonna move. It's gonna cause extra growth of the database that you now need to maintain, and nobody's reading the table. It would have been fun, but that would have been it.
Exactly. However, you can use, the traditional reasons to do a table partitioning, separated by year, quarter, whatever. So as we saw from our trending, order header was by far one of the busiest tables in the database. I think there was only one other table that was being read just as much as order header. But capturing the trending information over time, we saw this blue trend line here. This is order header. So we knew this is where we're going to try it first. And we also took a couple of samples using the Protop real time, which is the character version that shows you what's going on in real time and available free. And that's another way to check and see what the busy tables are in your database. So to summarize the steps, like Mike went through in most of the demo, introduce the integer field for our tables, introduce the areas for those new indexes and fields, enable table partitioning, which we can do online, create the partition policy, and then relocate the records to the new area to actually do the record move. And
yeah, I can take it from here. Okay, so that's an environment, OpenEdge 11.7, CentOS, virtual machines. Like, as I said, each customer for us, we obviously pick the biggest or whatever, one of the biggest customers. 700 gig data, it's way more now. 2 months later, whatever, it's way more. And as I said, it's in logistics, so constraints about downtime. So how we did it? Introduce the field. tourism versus immigration. It's piece of cake, right? Introduce an integer field, introduce an index. For the big table, Nectar mentioned, it took hours to make an index. If you do it through data dictionary, so it was not acceptable. So we had to find some workarounds. Nectar came with this idea. Instead of just making a new index, we introduce inactive index, and we do
An index rebuild.
index rebuild.
Yeah,
Like,
which
so-
does require some downtime.
Yes, so we kind of, we're not lying, but all those steps were done way before we really did migration of records. So we used the downtime, but we're talking very short downtime. We use the downtime for schema change because it happens every once in a while. The new version, requires new schema. So we did it up front. Loading as inactive index. So we actually took down from 4 hours to pretty much less than 10 minutes. So that's a workaround. If you have to do it, it still, still needs downtime. And right after we did it, Mama said, we don't have to recompile.
Don't need to recompile our code.
We had to do it.
First says don't recompile our code.
Yes.
The holder has
real-
experience.
Environment, what happened, it's a homegrown application, okay, built in-house with our developers. Some code is dynamically built using orders. So we obviously changed something in a schema, and most of the 99.9% of screens were working fine. One particular screen was giving us this, and until we did a recompile, everything was working. So that was
Unexplained. You should not have to recompile. This was a surprise.
whatever he
We don't
said.
know. We couldn't get to the root cause analysis of this, so
Yeah.
we have no root cause. But you should not have to recompile. But it broke. They needed to fix it. The fastest thing to do, recompile. move
Recompile,
on.
yeah.
And they did.
And by the way, the CRC is not changing. So that was a best proof. When Mike said CRC doesn't change, this tiny little field, this index, not being used in any applications, no need for recompile. I'm a living proof. We need. Okay, so how you do it? First of all, we have a running database. We can enable table partitioning, as we said, online. That's pretty much the steps. When you see the table partitioning, not enabled yet through OpenEdge management, you just click on enable, getting some message warning, table partitioning successfully enabled, or you can do it through character interface, enable table partitioning. And by the way, when database is replicated, everything is being immediately reflected in the target database. So whatever we do, introducing, enabling table partitioning, it's immediately translated to the target. So the way to check it, the easiest one, pro-util describe, right? And you see now table partitioning as yes, so it's enabled. Next step, create the partition policy. So we obviously had to pick the, you pick the name. You have explicitly, select the database, pick the table, define area, and obviously, for doing transitioning of records to the new, you have to introduce the new storage areas, which meant, to keep the new records relocated. And very unexpected, very strange reason, we seriously didn't see it before. It's blast from the past, from 90s of last century. We suddenly see the possibility of having 2 different tiers of storage. Remember, in 90s, last century, it was a slow disk and fast disk. fast disk, more expensive. So interesting enough, in an environment which is provisioned, we facing now this possibility. It's not happening yet, but we might start using the slow disks, believe it or not. And by the way, the best way, Nectarius probably can show you on the disk, what's the best way to check the performance of the disk?
Yeah, it depends. So like unbuffered write test, we call it the Furgal test, growing the BI file, or sync.io from Protop, how quickly we can grow the BI file. And that gives a pretty good metric.
Anyway, that's how we did. We create a partition policy, you click next, you go into, oops.
And one quick note on this. So we did this from OpenEdge management, but if we need to do this over 100 databases, we can do this on the back end using an SQL statement.
That was an idea how to scale it. So we obviously did it manually pretty much, like for one of the biggest customer. But the whole idea is to to use the same process or multiply for many others. So pretty much like what we're doing here, we selecting the field. That's the field we introduced. What you saw in the definitions. We introduced the tiny little integer field, order header. Order header is the name of the table, and underscore archive means like if it's 0, it's sitting in the old area. If it's 1, it's moved to the new area, storage area. Next step, create partition policy detail. Interesting discovery. You cannot keep adding, but once you introduce one policy detail, order header underscore archive equals 0. What it says, it stays in the default in the original storage area. Like what you have to do, you have to commit it, and then you can add another storage area. I don't know if it's a fluke or that's exactly what we found. The whole idea was like to find the issues in real life.
This is why you don't use this user interface. You use SQL and make it repeatable.
Okay.
And by the way, when we were doing this online, there was a process actually interfering with this that we had to terminate so we can move forward with it.
Yeah. Right. So, as I said, that's a second line. When order header underscore archive equals 1, it has a different destination, and that's what we didn't use it yet pretty much, but there is a facility to generate policy programs. So once you have this partition and partition policy details enabled, you can literally click generate policy program, and it gives you something like that. It's actually longer, but whatever. So that's pretty much the idea how we want to use it to scale. Like you grab this and you migrate it to another database, or if you want to do, that's what we still want to do with different table. We only did like one big table. If you want to do it with different table, you can massage this program, changing the name of fields and tables, and you continue with other databases. When we started relocation, we tried to start relocation. Immediately we got like trigger issue. It was kind of obvious. Trigger issue, schema trigger. Application is using like some programs like to, that's the reason of having the huge audit table. Pretty much, it's the old way. I know we can use CDC these days and stuff like that, but 20 years ago when it was created, every transaction was captured before and after state for possible forensics and in the future. It's kind of old way. So we had to bypass somehow those triggers. First idea was we can disable triggers. No. Because we claim it can be done online. we still want, the regular process to go just, normal way, making those audit records. So simple solution. Triggers can be disabled in a piece of code, and this is pretty much the piece of code which moves records. So you only changing the value of one field from 0 to 1. By default it's 0. You change it to 1, and magically record move to the new storage area. Can be throttled with pauses. That's what we expected, like really, because Mama said it will slow down the application. So that's how you prepare this, like, split it in chunks of 10,000 or whatever, 50, whatever, 5,000 you did, and introduce a little pause. 10 seconds probably it's too much, because, like we're talking the table, 10 gig worth of data, 10 million records, right? Something like that.
Yeah,
10
exactly.
million
10 million
records.
records.
So maybe 10, this is in seconds, by the way. 10 seconds for each chunk, probably it will, extend the relocation time, like for what, a few days. But that's the way to throttle the process. As Mike said, you have full control. We can use different index. Like if you don't want to use a default index, we can technically use a different index. You can, do chunks, 10,000 or whatever. That's pretty much the idea, and that's how we did it. And we did the whole setup to monitor what's happening during this relocation, because that was the main idea, right?
Right. So we chose, even though we can do this online, because it was the first time we're doing this, we still picked a quieter period. So we could see there were still some users. These are connections here. You may not be able to read it. There's still some connections here, something like 30, 40 users, I believe, connected. And while this was happening, there wasn't much impact on performance. So we have the user experience graph here, and our reads per second in shared memory. They didn't really change much at all. We're still getting that consistent throughput of read performance, and same thing with writes. So down here, this is the Furgal, aka sync.io test, where we're growing the BI file. So maybe a little hiccup over here, but otherwise, no change in performance. And so we can see here, these were the database reads happening so the entire process took about
8 hours.
8 hours, 11 o'clock till 7 o'clock. So we could see here all the database reads and the database writes here, more or less at a steady 300 records per second. Although we were doing this, the majority of the activity wasn't even with that order header table, so it was eclipsed by other tables that you could see here in orange. So behind there is the order header table, but it wasn't even the busiest table. So in terms of impact, it was pretty minimal, which we found out. So we could see here our table reads, creates, and index creates, deletes, more or less at around 325 records per second. And it was pretty steady throughout. And aren't you glad we didn't pick the audit table for that, the 200 gigs, I don't know. Yeah, so this was 10 million records, took more or less 8 hours. So some other observations, we're also looking at the system for stuff like latch weights, looked at the BI file growth, and surprisingly enough, there wasn't much BI activity. There were, however, lots of AI writes. So on a typical day during the same period, last week it was around 200 megs of AI files, and when we did this, it created 231 gigs of AI files. So be ready to have that space available when you do this. So I mentioned it took about 8 hours.
Nectar, And when we talked about huge AI, like welcome tomorrow to Gus presentation about AI, and he explained like why exactly it happened. So tomorrow morning, right?
Yes.
Right. So at the end of all this, we can look at the partition status and see all the records were moved. So 0 records in the former area, and in the new area we have all our records here. So post-relocation results, running the DB analysis after the fact. So we could see here our fragmentation was 20% with a 1.2 factor. And after relocating, our fragmentation was eliminated. So at 1.0. And we could see here, so the record count doesn't exactly match because the database was still being updated online. And this is you.
Yeah, and that's how we wanted to present. Like, initial idea was to use some standard business process, like report, existing report, and show, like demonstrate to business, like it takes like way less. But problem with business was they using different parameters like every time, so like it's not consistent. So we came up with simple, for each, like just count records program. Just and measuring the time it took like to count all records. So like before the relocation, during work hours, like with like pretty much many customers, like 130 users, it was like average like 80 seconds, and we did it like multiple times. Obviously, it's not just one measurement. We did it multiple times, removing the shortest and removing the longest. Average was 80 seconds. When we did some experiment online, so database was online, but we temporarily disabled all users' activity because we didn't know exactly how big will be the impact. We noticed like in a few minutes, like pretty much like no impact. So we enabled everybody to log in and keep doing transactions during the relocation. But it was a weekend. It was what was a Sunday. It obviously was longer, and like literally after in the work day, Monday, it was literally half of the time it was the working day before. So for us, it's a KPI. It's indication we did a good job. Like as Nectarius mentioned, it's the busiest. Sure. No. What we're really doing, we're only changing one tiny integer field. The integer field we introduced, we're changing the value from 0 to 1, and it dictates because of the policy to migrate this record. So this program we're talking about here just does. It doesn't involve any storage area. It's just for each order header, count, like cycle. What's the lapse time? Like what? It was taking like 80 seconds just to go through all of it because fragmentation pretty much disappeared, right? Suddenly it takes like 40 seconds, and because it's a busiest table, that's.
I think your question is, so now you add a row, and that row's initial value is 0, and that's going to end up being put into the original storage area, not the new storage area. Is that your question? Yeah, so as part of this process, you need to go change the schema to change the initial value to now be 1. Because once you moved it and say everything now is in the 1 storage area, you want new records also to be in the 1 storage area. So you need to go make that schema change to change the initial value.
Or
Right. So if you're gonna clean up the space and remove the old one, you need to remove the petition in order to keep the records in the same storage area. So you could either keep the petition policies in place, change the initial value so all new records end up being in the new location, or once this is over, you can go remove the policies, disable petitioning, and then you're back to normal.
Yeah, and that's, I think it's a brilliant idea. Like after we move everything to the new storage area, the next idea was, like, what if we do it like, in reverse? So we change the value, the same style, from 1 to 0. Guess what happens? Everything moves back to original storage area. Unfortunately, it doesn't release the space, so new storage area space taken, right? So we're not releasing the space. So you have to use, some downtime later probably to truncate this area. But hey, moving everything to the new storage area and moving everything back pretty much means dump and load online, just like Mama said, right?
You're right, you don't have to
Yeah,
change
and you don't have to change
if
the
you move
initial.
it out
Yeah.
and move it back,
Yeah.
then you don't have to change the
Yeah.
initial value. So I think this slide shows a point. 20% fragmentation. Fragmentation is record to split between multiple blocks, has a big impact. We don't have a really good mechanism in DB analysis to show you what the logical scatter is. We used to be in type 1 storage area, that scatter factor was very, very useful. But in type 2, you're no longer physically scattered ever. So it's, unless you did a huge purge, your scatter factor might be something different than 1.0. But the fragmentation factor still matters. 20% fragmentation, 1.2, it has a big impact. In the demo you saw, I had a 2.0 fragmentation factor, so that every single record was fragmented. It went from 10 seconds to 5 seconds at the end. Huge, huge impact. Gus, you want to
Yes.
heckle?
Yeah, besides the eliminating the fragmentation, there's another effect which helps with performance, which is that when you move all the records, you're doing a for each, and those new record, or those moved records end up with their physical order matching the default index,
Yep.
which may or may not be the case in their original location. Probably not if you've been working with that table for some time. It's probably randomized pretty well.
That's
So-
exactly
so
the
you
case.
get the ordering matches the index.
In the most optimal way. And and as we discussed, like we can use a different index, so not necessarily the default index. Yeah, exactly. So like all the ways to improve it. Anyway, as
Okay, and here's the problem.
back from tourism to immigration. Monday morning, like now he has it in his slide. Like he didn't have it before. Like I swear to God, you didn't have it in the original one. Like,
I didn't have it in the original one, but I had it. We talked about this also in our bucket talk tomorrow.
So like,
Oh, Patrice is here.
Yes, just for the space, you can use the table move, with the table partitioning for the initial partition. So we remove the space.
Did we? Patrice, are you asking that after the table partitioning moved, did we remove the space? Is that what you're asking?
Something like 1,000 records, which is with the value 0.
Yeah.
But the space for this partition is something like 7 gig.
Right, 10 gig at least. Yeah.
Yes.
10 gig this time, yeah.
You can use table move, initial partition, to another area.
Sure.
The
Yes.
space with
Right. So,
partition.
Patrice's point, which is a really, really valid point, if you're going to move to a new storage area and then move back, now that storage area that you moved to and now you move back into your original one, that's just a work area. So now you can do it for another table and move another table that you want to work on and move it to that storage area that you already used previously, and then move it back. So you can make this part of your database as being a work area. And not delete it all the time. I think that's your point, Patrice, right?
Yeah.
Question in the back?
How does it compare to table reorg?
So that's a really good question. What are you doing tomorrow? Because we're going to talk about that in the bunker talk. So I don't want to give too much away. So come to the bunker talk and we'll talk about table reorg.
So this particular, unpleasant discovery was, when we had like for more than a day, 100 users transacting, who is using Rec ID? He's gonna ask, right? No? No? Okay. Yeah, okay, that's right. So, one particular program out of like few hundred was using Rec ID, believe it or not. It was like really fixed quickly, and we still had to consider and to provide some sort of contingency procedure. So we find some issues with that. Like for example, if you have a composite, it's not easy way to just remove
Right.
policy detail.
Rolling back is no easy feat, but we had to be ready for it in
Yeah.
case we couldn't fix this Rec ID issue. So the first option would to do a full dump and load, which kind of defeats the whole purpose.
Yeah.
6 hours, and then the other option is to dump just the table, which is still a significant amount of time, but much less than a full dump and load. And these were the steps we were ready with it. Shutting down the database, dumping order header, changing the policy, truncating it, dropping the table, and then reloading everything back in. So luckily it was a quick fix. It was one include file and took care of the problem. But these are kind of things you have to be ready for when you do this in production. So in conclusion, so it can work. We've proved it, but there's some caveats. We ran into some little surprises that you have to be ready. So it's not a one-size-fits-all solution. I'm not telling you to go ahead and do this for all your production database. I mean, you have to consider, is allocating that extra space worth it, that extra work area? But in certain situations, it may make sense. If you need to do this often to eliminate the fragmentation and keep performance in check, it might be a viable solution. So it's something we need to look at on a case-by-case basis and see if it makes sense. And finally, can't stress this enough, test, and then test again, test, because
It's obvious.
yeah, like a lot of these issues we had uncovered in the test environment, like the trigger issue and things like that. So very essential to do it on your test environment. And with that, I think we have another 3 minutes for any other questions.
So the point is to eliminate fragmentation. In the long run, when you move the data back to the original storage area, aren't you just going to start fragmenting again because you have the wrong rows per block or something to that effect?
Yep, that's a good point. So if we change it back to the old area, then yes, we're going to have that issue. But I like Patricia's suggestion in using the table move to move it to the table to another area.
To another area that has the correct records per block is Tom's point. That record fragmentation can be avoided. It takes some analysis, takes some effort to do it, but it can be avoided.
You use only two values. I think you can use several values. For example, you could have
That's right, yeah.
doing this, you can move back to zero, only the Q value here.
Mm-hmm.
And for next time, you do not have to modify the old data.
To the different,
Yes. to another one.
another yet introduced. Yeah, that's a great idea. Yeah,
Yes. And
it's the next step, I
this
guess.
You download every year, you have only the data for this year
Mhm.
back. And you will save a lot of space with this.
Yeah,
Good point.
that's a good point. Yeah.
Yeah.
And one last thing, we were thinking how to scale the solution. So we did it pretty much manually for one big database. How to scale it? As we mentioned, we can use the the generate program, massage the program, or we can do it through SQL interface. Gus way.
So the user interface that you were showing, underneath that, it's all 4GL code.
That's right.
So everything that that interface does, plus more, you can do with 4GL code. Unfortunately, there's a big learning curve to learning the APIs that are there, but it can be done. I and Mike did a talk on table partitioning a few years ago.
2016, that's 15 and 16, right?
Yeah, and in that talk, if you can get the slides from wherever they got posted, there's examples of both ways to do it.
And there are a couple of presentations on YouTube even, how to do it through API.
Yeah,
Yeah, just,
so you pick the one that is easiest for you.
Yeah. So if you're doing one environment, maybe the UI makes sense. You're doing 100, might be worth investing some time. And
that's a scaling, yeah.
yeah. Stop by our booth. We are giving away a few goodies, and would love to hear about your reorganization challenge or suggestions and feedback. And with that, thank you again for coming to our session.
Thanks, man.
Nice job, Vladimir.